Is everybody okay? Oh, what an event. We made it back into teams here. Oof. Okay. Oh boy. There we go. And we're good. For now. Okay. What do we think of this one? Kind of fun, right? It is maybe, Janiyah, you're going to dislike this a little bit because sometimes you don't know what rabbit you're chasing. You know what I mean? Like, you got to do stuff and think, does this make sense? Okay, this must not be the contradiction I'm trying to reach. And you got to keep going because you don't always know where you're going to break the math. And so sometimes that's uncomfortable. But we got to just keep on keeping on. Okay, so let's do the next one. We got to do scratch work so we can all think, right? Yes. You're going to love this. This is one of my favorites because it's not very obvious. Okay, so to do this with a contradiction, we're going to assume instead that a squared minus 4b equals 2 for a, b, and c. A, b, in z. That's how, like I said, a, b, and c. A and b in z. Integers. Okay. Ready? So a squared is equal to 2 plus 4b. You good? This is 1 plus 2b inside of there times 2. What does that mean about a squared? Sure is. So a squared is even, which means that 2 divides a squared. You with me? Uh-huh. What does that mean? Shoot, where did it go? Oh, yeah. Here. Using this result. So if p divides n to some power, then p divides just n. Okay, so 2 divides a squared, which means that 2 divides a. What does that mean about a? That a is equal to, See, this is the thing. I know the rabbit we're chasing, you know. Michael might have just figured it out too. No? Yes? If I plug this in up here, sure do. I get an even equals an odd, and that's uncomfortable, isn't it? And not just uncomfortable, it's wrong. So because I plug that back in to where I have a squared equals 2 plus 4b, or a squared equals 2 times 1 plus 2b, I square that, I get 4k squared, right? And then I can factor 2 away from both sides. So I'm looking at 2k squared is equal to 1 plus 2b. That's an even equal to an odd. Because k squared and b are both integers. Those are definitions of even and odd equal to one another. And as you know, we have proven that every integer is either even or odd, not both. Right? So there's our contradiction. So let's write a proof.
Much better than checking all possible integers.
Correct. Suppose not. Suppose instead that a squared minus 4b does equal to. Then a squared equals 2 plus 4b, which is 2 times 1 plus 2b. Since 1 plus 2b is an integer, a squared is even. Thus, 2 divides a squared. And since 2 is prime, this only works for prime things. Since 2 is prime, 2 divides a. Then a is equal to 2k for some integer k. We have a squared equals 2 times 1 plus 2b, which is going to be 2k squared, which is 4k squared, which is 2k squared equal to 1 plus 2b. This is an even integer. Uh-oh. Go way back up here. And go ahead and make sure that we know those are integers. Sorry. Because if not, we haven't really reached a contradiction. So this is an even integer equal to an odd integer, which is a contradiction. It must be that a squared minus 4b does not equal 2 for all a, b, in z. Good? Questions? Comments? No questions or comments? None at all. We're doing fine. Yes?
So like, we could also say, is it just for two, you said the number, where it's like the number divides a squared, and then
It's any prime.
any prime?
So if it's 5 divides a squared, then 5 is going to divide a. If it's one of the prime factors of the thing to a power, then it's going to be a prime factor of just the thing. Because you can't come up with more prime factors when you're just raising it to a higher power. But it only works for primes. Okay. What do we think so far? So good? Okay. Difference between contradictions and contrapositives. What do you do for a contrapositive proof? Huh?
Yes, which
Yeah, you assume not Q and show not P, right? What do you do for a contradiction proof? You assume P
Mm-hmm.
and not Q. Show that has to be false. Meaning that the P doesn't apply Q.
Mm-hmm.
Good? Questions? Comments? No? None at all. We're doing fine. Yes?
So like, we could also say, is it just for two, you said the number, where it's like the number divides a squared, and then
Meaning that P does imply Q. is true. Yeah. So like the hardest part about doing some proofs and sometimes is like knowing how to start. Should I prove this with a contradiction? Should I prove this with a contrapositive? Should I try to prove this directly? I think probably the people would tell you that mathematicians would go in that order: direct, contrapositive,